Alright, this is the reactions of alkenes. So alkenes generally undergo addition reactions and oxidation reactions. Alkenes, because of the double bond, are quite reactive because they want to get rid of the double bond and then add things on. So the first type of reaction that you will experience is halogenation, and you're either adding chlorine or bromine, both of which should be added to water. Okay, that doesn't mean water takes part in the reaction, it's just that there's water dissolved in it. Okay, chlorine will have no colour, bromine, you can either call it orange or brown, and then when it reacts with the alkene and adds on at the double bond, there will be a colour change to colourless. There'll be no colour change for chlorine. So bromine's probably the most important one to know because it has a colour change. Alright, so you can see that with the double bond, you're adding something on to the double bond, it's gone, and we add a bromine to each side of the double bond. Right? The next type of reaction is with hydrogen chloride, and that reaction involves adding on an H and a Cl, okay, at the double bonds, and you could get Markovnikov's rule here. So for example, if the alkene is not symmetrical, that means that it's got 3 carbons in it and the double bond is at one end. You can get a major and a minor product. Just remember that the major product is always where the rich get richer, or the carbon with the most hydrogen atoms will become even richer in hydrogens when it forms the major and minor product. Alright, otherwise we can add hydrogen. Hydrogen is either with a nickel catalyst in 200 degrees Celsius or with a platinum catalyst. All you really need to know, double bond is lost and an H is added onto each carbon in the double bond. Hydrolysis involves the breaking of a alkene double bond by adding water. Okay, so hydro means water and lysis means to break. That's either with an H plus catalyst, meaning acid, or with, often you'll see, dilute H2SO4, that's dilute sulfuric acid. So you can see that the OH is added onto one carbon and an H is added onto the other carbon in the double bond. That's also going to have the possibility of having a major and a minor product if, for example, we have propene as our molecule. Right, so same rule, the rich get richer with propene. Finally, they undergo oxidation, and oxidation involves potassium permanganate, this thing here. Alright, it's a pretty weird sounding name, but all you really need to remember is that it's purple. Sometimes you see it written without the potassium because it doesn't actually react. So you might see it as MnO4 1-. You have to add H plus in here, and the reason why you've got to add H plus is because it's a catalyst. So an oxidation reaction is just like an addition reaction, double bond is lost and OHs are added onto each carbon in the double bond. You will see a colour change of purple to colourless. So this plus the bromine one are the most important because they have colour changes.